What if the Earth suddenly became twice as big? How would life on our planet change? We'll tell you further. The volume of Earth's core is about 1.6 trillion cubic kilometers. It's a huge amount, but scientists estimate that the Earth's mantle contains from 1.8 to 3.6 quadrillion cubic kilometers of rock. So the core is just a tiny fraction of the entire planet. What if it expanded? To make the Earth bigger, we need to increase the volume of the mantle. Let's add a layer 100 kilometers thick to it. That would require about 1.2 quadrillion cubic kilometers of material. Where can we get such a huge amount of rock? Scientists have an answer for that. In the Earth's mantle, there is a so-called transition zone where rocks are under enormous pressure and temperature of up to 500 degrees Celsius. Because of that, minerals in the rocks are squeezed, which makes them denser. As a result, they literally glue together and form an incredibly hard substance. It's called bridgemanite. The thing is, bridgemanite is stable only at high temperatures and pressures. On the Earth's surface, it decomposes very quickly. But scientists suggest that in the early stages of the Earth's formation, the conditions were quite different. Back then, the young Earth was much hotter and had many more metals. And bridgemanite played a key role in forming the planet's core. This means that if we find a way to recreate those conditions of the early Earth, we can synthesize a lot of bridgemanite and use it to expand our planet. Let's take a closer look at how this process can be carried out. First, we need to find a source of high temperatures. It could be the remains of a meteorite that fell to the Earth's surface not so long ago. Scientists have calculated that the core of such a space body could reach 10,000 degrees Celsius. That's about 8,000 degrees hotter than the center of our sun. We also need high pressure. And for that purpose, we'll use one of the most powerful lasers in the world. Currently, the most powerful laser is the ELI beamlines laser in the Czech Republic. Its power is 2,000 joules per pulse with a duration of 30 femtoseconds. In other words, that's a very short 2,000 watt laser. Just one pulse of this laser focused on a spot the size of a pinhead creates pressure up to 100 gigapascals. That's about 1 million times higher than the pressure in the Earth's mantle. Now let's see how we can combine these two factors. A team of researchers from SLAC National Accelerator Laboratory in California has already performed an experiment that simulates the conditions inside the Earth using a similar setup. First, they heated a diamond anvil to 5,000 kelvins using a powerful laser. Then they placed a sample of bridgemanite between the anvil and the anvil. Under such high temperatures and pressures, the bridgemanite started to decompose and released a huge amount of energy. This process can be used to synthesize new bridgemanite with the same properties as the one found in the Earth's core. We can use the released energy to power cities. And we'll have a lot of material to expand the Earth. But even after adding a 100-kilometer layer to the mantle, our Earth will still be only a little bigger than a basketball. You probably think that increasing the diameter of the Earth by just a bit won't change much. However, everything will be completely different. Our planet's gravity will be 19% stronger. That's almost as heavy as on Jupiter. People will become 20% shorter and stockier because of the force of gravity. And the bones and muscles of future generations will be much stronger. Earth's atmosphere will become denser, which means that oxygen will contain less nitrogen. That's why breathing will be harder and it will be much colder. The climate on Earth will become like the one on Mars, and it will be really difficult to survive on the planet without spacesuits. But we can stop global warming once and for all since the Earth will be enveloped in a thick layer of ice. Moreover, with the increase in gravity, the oceans will become deeper. Water bodies will reach a depth of almost 4,000 meters. Underwater cities will become a reality. And since there will be much more water, precipitation will be abundant. There will be many rivers, lakes, and swamps on the planet. All deserts will turn into fertile lands. Agriculture will flourish and humanity's food problem will be solved once and for all. And yet, despite all these changes, we won't be able to see the other side of the Earth even from space. You'll need to leave our solar system for that. Watch our video on what will happen if Earth gets twice as small and check your facts. See you later.